Alright, good day everyone. In our last video, we talked about using abridged and truth table to test the validity of an argument. So in our today's video, we are going to be discussing the rule of inference. And rule of inference are 9 in numbers. They are just like shorter arguments that we use in proving a longer argument to be valid. So we are going to be explaining the rules first, then I will give us examples on how to apply them. The rules are 9 in numbers, like I said, and I have a shorter ways for the purpose of remembrance. I have a shorter way that I use in learning the rules. So I called it Adam's HCC. That is, as long as I can remember Adam's HCC, then I remember all the rule of inference. So if I can remember Adam's HCC, then I will remember all the 9 rules of inference. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is absorption. This is disjunctive syllogism. This is addition. This is modus ponens. This is modus tollens. This is simplification. This is hypothetical syllogism. This is conjunction, while this is constructive dilemma. So once I can remember Adam's HCC, I remember all the 9 rules of inference. So I'm going to be explaining them one after the other. Then I'll give us example on how to apply them. So the first one that I'll be talking about is absorption. Absorption, that is ABS. Then the rule for absorption is P implies Q. Therefore, P implies open parenthesis P and R. Absorption. What this rule of absorption is just saying is that if we have a statement P implies Q, we can infer the conclusion, which is P implies P and Q. And another thing that you need to note in logic is that what matters most in these rules is just the form. The content does not matter. The content can change. As a matter of fact, when you start making use of the rules, you will realize that you'll be having different contents in which P and Q will not matter anymore. So it's just the form of the argument that is the most important thing. What I'm trying to say is that P implies Q is still the same thing as T implies U. If we want to use absorption for this kind of arguments now, it's going to give us T implies open parenthesis T and U close parenthesis. So the content itself does not matter. What matters most is the form. So the second one is disjunctive syllogism. Disjunctive syllogism, which is popularly known as DS. And this is the rule for DS: P or Q, negation P, therefore Q. So if you have P or Q and you also have negation P, you can infer the conclusion, which is what? Q. Don't forget that there is a difference in between absorption and disjunctive syllogism. In absorption, you have just one premise, so you need just one premise to infer the conclusion. While in disjunctive syllogism, you have 2 premises. You need these 2 premises, the first premise and the second premise, for you to make use of disjunctive syllogism, for you to infer the conclusion using disjunctive syllogism. Just like the content does not matter in absorption, the same thing applies to disjunctive syllogism. So it's still the same thing if we have something like A. Let's say A implies T in parentheses, or V negation A implies T close parenthesis, therefore V. So this still works for disjunctive syllogism. Like I said, the content does not matter. And don't forget that when we did our symbolization video, we said anything that is in parentheses means one thing. It has been grouped together. In other words, this is still our Q. Forget the fact that we have A implies T. As long as it is already in parentheses, it's already in this bracket, that means it's already grouped together and it's still standing as our P. Or then this V is our Q. Negation P, that is negation everything here together, so that's negation P, therefore Q. So it's still the same thing. So when you start applying those rules, you see that you will not even be saying P and Q anymore. So you don't really get used to P and Q and be looking for P and Q every time you want to make use of the rule of inference. So the third one that we'll be discussing is addition. Addition says that what P, therefore P or Q. Like I said, what this thing is just saying is that addition also has just one premise, just one line, then you can infer the conclusion. What this one is saying is that if you have a variable, you can use this disjunctive sign to add another variable to it. In other words, if you have something like P and S, you can even say therefore P and S or T. All you just have to do is to group them together, then add whatever it is that you want to add to it using this particular sign. So addition is saying that what P, therefore P or Q, P and S, therefore P and S in parentheses or Q. So it's as simple as that. Then the next one that we'll be discussing is number 4, modus ponens. Modus ponens is telling us that P implies Q, P, therefore Q. Like I said, don't get used to the content so much. It is the form that matter. In this addition, I think that if there's one thing here, we can say therefore using this particular sign to add another thing to it. So if we have one line, we can use this particular sign to add another thing to it. Here I added T. So what modus ponens is telling us here is that if you have something implying another one, and on another line you have the first one, then you can infer the conclusion, which is the consequence of the first line. So you can also have it to be like something like P, or say T, let's even say T or S in parentheses implies A and B. Then you have T or S, therefore A and B. As you can see, this is still our P implies, and this is still our Q, because it's already grouped together, it's already in parentheses. Then we affirm the P in the second line, so we are bringing down the conclusion, the Q in our conclusion. So it's as simple as that. Then the third one is, the fifth one is modus tollens. Modus tollens. So this one is saying that P implies Q, negation Q, therefore negation P. I don't want to go too far, but it's still the same thing as, let's say, A, if I know the if B in parentheses implies T, negation A, if I know the if B, negation T, therefore negation A, if I know the if B. So this is still our P implies, and this is still our Q, negation Q, therefore negation P. So when you start making use of the rules, the content will keep changing. The content will keep changing depending on the kind of argument or the variables that they use in those arguments. So what matters most in this rule is just the form that, okay, if you have this thing to be like this, so you can use the rule of addition or modus ponens or modus tollens or disjunctive syllogism to derive the conclusion. Then the next one is simplification. Simplification says that if you have P and Q, you can say therefore P. So the same thing applies to it too. The content can change, but this is what matter, that if you have and this conjunction sign joining two different variables together, you can simplify the first one. That's all. Then the next one is hypothetical syllogism, popularly known as HS. This one is known as simp. So hypothetical syllogism, which is known as HS, is telling us that what P implies Q, Q implies R. So you can say therefore P implies R. So this one too is something that is very, very simple. It's just trying to tell us that what this one, if this one brought about this one and this one brought about this one, so we can say this first one brought about this one. It's just like saying that what your grandmother brought about your mother brought about you, so therefore we can say your grandmother brought about you. So it's as simple as that. And like I said, the content can change. It can be in any form. It can be something like P or T in parentheses implies S, then S implies SA, V and X. You can say therefore P or T implies V and S. Like I said, as long as it is already inside this parenthesis, it means one thing, and it can stand as our P. So P implies Q, Q implies R, therefore P implies R. So it's as simple as that. So let's discuss the last two, then I'll give us example on how to apply those rules. Then the next one is, is one of the simplest. That's number 8, conjunction. Conjunction is saying P, Q, therefore P and Q. In other words, if you have a different variable on different lines, you can use this sign, this conjunction sign, to join the two of them together. So the same thing as having T implies S, and also having, let's say, A or Z. You can even use conjunction to say T implies S and A or S. What you are just doing is that you are using this particular connective, this particular conjunction sign to join two different lines together. So if you have P, if you have Q, you can say therefore P and Q. Then the last one is constructive dilemma. Number 9, constructive dilemma says P implies Q and R implies S. You can say the second line will be P or R, therefore Q or S. In other words, P implies Q and R implies S. The first one here or the first one here or the first one here, therefore the second one here or the second one here. So what all these rules are just saying is that, like I said, the content itself does not matter. They can change. What really matters most is the form. Like, okay, if you have something like this, you have something like this, you can use this sign to join them together, saying that you make use of the rule of conjunction. Like P and Q that we're having here can be T, it can be S, it can be V, it can be anything. What matters most is that if you have something implying another thing that is together and another thing implying another thing that is together, you can say, and you also have the first one here or the first one here, then you can use the rule of constructive dilemma to say the second one here or the second one here. The rule of constructive dilemma is popularly known as CD. So you can just say the second one here or the second one here. And don't forget that there are some rule of replacements that have two different premises, while there are some that have just one premise. So in the ones that have just one premise, all you just need to do is to have the premise, then you derive the conclusion. But those ones that have two different premises, for you to make use of them, you have to find a way of getting the second premise that is going to make it the first and second premise before you can infer the conclusion using that particular rule. So let me just quickly give us some example on how to apply those rules. So let us assume that after symbolizing here, we have something like M implies N, N or open parenthesis O and P, close it, negation N and negation Q, therefore O. Now let's say this is the question. After symbolizing, this is what we have. Then the first thing that you do anytime you want to solve using rule of inference, this is just rule of inference, we don't need rule of replacement here. The first thing that you need to do is to look at your conclusion. But before then, you have to first and foremost number it. Number 1, number 2, number 3. You number the premise and you put the conclusion by the side. The conclusion is supposed to be by the side, which is O. So you want to be applying those rule of inference, addition, constructive dilemma, or whatever rules that we just talked about. You want to keep applying those rules until you get to this conclusion. So once you get to this O, you will stop. You've answered the question. And if I were you, after symbolizing now, you want to start applying the rule. The first thing that you look at is your conclusion. That is, my conclusion is O. And you ask yourself, where do I have this O? And how am I going to get to this conclusion? This is where the O is. If I can actually find my way of bringing down this O and P, then I can use the rule of simplification just to simplify the O. Sure you get. So you just keep applying different rules until you arrive at that O, then you will stop. So the first thing that we do, I've already looked at it, I know my O is here. So I want to find a way to bring out this O. And to bring out this O, this is the first line of disjunctive syllogism, this place. Disjunctive syllogism said that you have P or Q, and you also have negation P. You can say therefore Q. That means in this place now, if I can actually find my way to bring out this O and P, I will just use the rule of simplification to simplify the O. But in this place now, this is the first line of constructive dilemma. For me to bring this O and P, I need negation M. It's a P or Q, negation P, negation P. So I need negation M. Once I have negation M, I will just say I use disjunctive syllogism with this particular line to bring out O and P. So how can I get negation M? Okay, I'm still looking at it. How can I get negation M? This first liner is M implies N. If I have negation N, I can say therefore negation M using modus tollens. So I need negation N also to get negation M. Then from that negation M, I can use this to get O and P. Then I'll use O and P to get the O that I'm looking for. So what can I do again to get the negation M? You know, in this place now, M implies N. If I have negation N, then I can say therefore negation M using modus tollens. And I don't have negation N yet. Then what can I do again to get negation N? My negation N is here. All I just need to do is to simplify this negation N, and I've already solved all my problem. So I will just say number 4, negation N, simplification. That's 3, simplification. So after writing out the conclusion, you just write the number that you work on and the kind of rules that you make use of. So number 3, I just did simplification. Simplification says if you have P and Q, you can say therefore P. That is, if you have this one and this one, you can simplify the first one. So all I just did in number 3 is to simplify the first one using the rule of what? Simplification. So I wrote 3 is simplification. Then I now look at it again. I already know what I want to do because I've already checked it very well before I start. Then I'll say number 5. M implies negation N. Negation N, therefore negation M. So I will say 1 and 4 empty. 1 and 4 empty. That is, empty told us that what? P, modus tollens. P implies Q, negation Q, therefore negation P. M implies N, negation N, therefore negation M. So 1 and 4 empty. Since we already have negation M in our number 5 now, it's going to make it easy for us to get the O and P that we are looking for. So all we just have to do is to say that what? Number 6. For now, number 6, we can now say O and P using 2 and 5 DS. You know, the rule of the disjunctive syllogism actually states that what? P or Q, negation P, therefore Q. So this is our P or Q, and we have the negation P here, so we can say therefore Q, which is O and P. So 2 and 5 give us what? Using disjunctive syllogism actually give us the O and P. Then number 7 will not be O. So all we just did is to simplify the O. So we say number 6, simplification. So the rule of inference is no more than that. All you just have to do is to keep applying the rule until you arrive at the given conclusion. So once you arrive at the given conclusion, you stop. That means you've answered the question. So let us quickly solve probably one more example, then we can move on to the rule of replacement. F implies G, G implies H, negation H, therefore negation F and negation G. So line 1, 2 and 3. So don't forget that we are just applying those 9 rules until we get to this particular conclusion. Now if you ask me, like I said, the first thing that you do is to look at your conclusion and you ask yourself, how can I get to this conclusion? Now from what I'm actually saying here now, if I have negation F to stand on its own and I also have negation G to stand on its own, then I can use the rule of conjunction to join these two of them together using this particular sign. So how can I make negation G and negation F stand on its own? I already have G implies H here. Then I have negation H. I can say therefore line 4, negation G. So I will say 2 and 3 empty. You know, empty says P implies Q, negation Q, therefore negation P. So G implies H, negation H, therefore negation G. So line 5. Since I already have negation G also, F implies G, negation G, therefore negation F. So line 1 and line 4 empty again. Then number 6. So negation F and negation G is what I'm looking for. I already have negation G to stand on its own, and I also have negation F to stand on its own. All I just need to do is to say negation F and negation G, 5 and 4 conjunction. Then I've answered the question. Then I'm sure that you'll be looking at is that why is it that I wrote line 5 and 4? Why not 4 and 5, since it is the numbering is from 4 and also 5? Why is it that I wrote 5 and 4 and not 4 and 5? If you should look at the conclusion very well, it states that negation F and negation G. It does not state that negation G and negation F. So that means what I'm trying to say is that the number, the line that you use first is the one that you're going to write first. So in this particular argument now, I use the line 5 first, that is negation F, before I use the line 4 and negation G. So that is why I wrote it as 5 and 4, and I did not write it as 4 and 5. Had it been I use negation G and negation F, that is when I can say 4 and 5. So that is all on how to the rule of inference and how to apply them. You can actually get more questions from the textbook or the past question. So thank you. In our next video, we are going to be discussing the rule of replacement. Then after that, we'll be discussing the rule of inconsistency. See you later.